We can now build on this to work out, if I'm given a particular acid or a particular base, what is the pH or what is the pOH. So the first basic calculation is this one. That's really important for moving from concentration of hydrogen ions to pH. What if I'm given an actual acid or an actual base? So there's four different possibilities. First one is you've got a strong acid. And it's actually really easy if you've got a strong acid to work out the pH. What do we do? Well, the acid fully dissociates. So if you have an acid like HCl, for example, it's going to fully dissociate into hydrogen ions and chloride ions. So the concentration of your hydrogen ions is going to be exactly the same as the concentration of your acid because it all dissociates. So if I have hydrochloric acid and I'm given the concentration of my acid, I can just say the concentration of hydrogen ions equals the concentration of the acid, and then I can use this and work out the pH. So to calculate the pH of a strong acid, you don't have to learn any more calculations or anything. You just say the concentration of hydrogen ions is the same as the acid, and then you use this formula. Now that's if it's monoprotic. Each acid molecule is releasing one hydrogen ion. If it was diprotic, for example, like sulfuric acid, that's a little bit more complicated because each of my acid molecules in the solution is going to release two hydrogen ions. So my concentration of hydrogen ions is going to end up being double the concentration of the acid. So if I was given a diprotic acid that was strong, like sulfuric acid, and I need to work out the pH, all I do is I start with my concentration of my strong diprotic acid. I'm going to have to double it to get the concentration of hydrogen ions, and then I can use my pH formula to get the pH. There's no new calculation there. It's just understanding the concepts of what's going on. So for a strong acid, what are we actually doing? We multiply by the number of H in the acid. So you multiply it by the number of hydrogens in the acid. That's going to be multiplying it by 1 or 2 or 3 if it was triprotic. But it's got to be strong so that it's fully dissociating. What if it's a strong base? If it's a strong base, it's exactly the same. Right? You would just multiply by the number of hydroxide ions in the base. So if, for example, I had sodium hydroxide, when that dissociates, it will form one hydroxide ion for each of these. So my concentration of hydroxide ions is going to be exactly the same as the concentration of the base. So if I'm given a strong base, like sodium hydroxide, my hydroxide concentration is exactly the same. I can then work out pOH using my standard formula. It's exactly the same as that one. And then I could work out pH because these two add to 14. So it's very easy to work out the pH of a strong base. And again, if it had two hydroxide ions in the formula, I'd need to double it to get my concentration of hydroxide ions. So a strong base, almost exactly the same, very simple. Okay, strong acid, strong base. What about a weak acid? That's where we get our second sort of major calculation we need to do. So the first one is this one. There is another calculation we need. How do we get from a weak acid to a concentration of hydrogen ions so that we can work out the pH? Well, you use the Ka, the acid dissociation constant. If, for example, I have acetic acid, it's dissociating to give the acetate ions plus a hydrogen ion. And I've got an equilibrium constant for that, which is CH3COO minus the concentration of that times the concentration of hydrogen ions divided by the concentration of the acid. That's our standard equilibrium expression for an equilibrium like that. We call it the acid dissociation constant. So if I've got a weak acid and there's an equilibrium that's set up, I'm going to have to use the equilibrium expression and the acid dissociation constant. If they just tell me I start with a weak acid and I need to work out the pH, they have to give me the Ka value. I can't do it without the Ka. They will need to give me the Ka value, and they will need to give me the concentration of the acid that I start with, and I need to work out the concentration of hydrogen ions. How do I do that? Because I've got two unknowns in my equation. So conceptually, what do? Well, I started with the acid and none of these. And all the hydrogen ions that I have come from dissociation of the acid. And so have my acetate ions. The concentration of these two is going to be exactly the same. Because for every 1 mole of this that dissociates, I'll get 1 mole of this and 1 mole of this. So in these sort of questions, where you have a weak acid, these two numbers, these two concentrations are always going to be the same because I started with my acid, it's dissociated, and it's formed these two things. So this is always going to turn into Ka equals the concentration of hydrogen ions squared over the concentration of the original acid. Now I would, if I was doing a work solution, I'd explain why that is, but it's going to turn into this. And so I'll know my Ka, I'll know my concentration of acid, I can work out the concentration of hydrogen ions. So how do I solve weak acid problems? It's always going to involve using the Ka, right? And I'll need to write an equilibrium expression. So I'm going to write an equilibrium expression for the acid. I'm going to use my Ka and I'll be able to work out the concentration of hydrogen ions. Then I can work out the pH. So that one's a little bit more complicated and you need to do practice questions. But it's only really the second big calculation you need to do. You've got this one, second one, you've got using Ka. Now there is one more trick. Often they will give you pKa. So they won't tell you the Ka of the acid is this value. Often they will give you the pKa. And you need to work out the Ka using the relationship between the two. pKa is negative log of Ka. And you can, if they tell you pKa, you can work out that, use that to work out the Ka, then you write your equilibrium expression and you can work out concentration of hydrogen ions. Now you need to do practice questions and see worked examples to understand this well, but it's the concepts at this point. How do we bring all of these things together? If you've got a weak base, right, really, it's exactly the same sort of question as this, but you use Kb. It's going to be an acid, a base dissociation constant rather than an acid. So let's sort of summarize what we've got here. If I've got a strong acid, a weak acid, a strong base or a weak base, I'm given the concentration and I'm asked to work out the pH. How do I do it? Strong acid, the concentration of hydrogen ions will be exactly the same as the concentration of the acid, but I multiply it by the number of hydrogen ions released by each molecule of the acid. Then I can work out pH. Strong base, exactly the same, but I'm using hydroxide ions. Then I can work out pOH and pH. A weak acid, I need an acid dissociation constant. I write an equilibrium expression. I can use that to work out the concentration of hydrogen ions. Then I can work out pH. Weak base, almost the same as a weak acid. Now, one other trick here. If you understand this well, you'll be able to solve a whole heap of different questions where they're testing if you really understand it. So instead of saying, I have 1 molar hydrochloric acid, what is the pH? They might instead say, if the pH of an acid is 0.5, what is the concentration? Like if it's hydrochloric acid. And then you'd need to say, oh, they've given me the pH of 0.5. I can work out the concentration of hydrogen ions using that formula. And then if I know the concentration of hydrogen ions, that's the same as the concentration of the acid. If it's diprotic, I would halve it to get the concentration of the acid. And you can understand how to do those calculations because you see all these relationships. This also means if they gave you a question like, here's a weak base, calculate the pH of the weak base, this allows you to see all the sort of steps you would need to go through to solve it. Originally, questions like that can be overwhelming because you've got the weak base, you've got Kb and the concentration, and you think, I don't know how to get to pH from that. But this allows you to see, okay, my weak base, I need an equilibrium expression in Kb, that will get me concentration of hydroxide ions. From there, I can work out pOH using the log formula, and then from pOH, I can work out pH because they add to 14. It helps you to break it down into the different steps you need to do. And if you're given a question like weak base, work out the pH. If you can't do this properly, you're confused, even just writing down concentration of hydroxide ions, POH equals negative log concentration of hydroxide ions, putting a number in and trying to solve it, and then using that to work out pH, doing some of the steps shows understanding. If you even just outline, these are the steps you need to follow, and tried to do some of them, you can get a lot of marks because you're showing a lot of understanding of how things fit together.